Okay, so now we're going to look at the lab number 3, and this is covering MS Build. Now, the actual threat we're using here is Cobalt Strike. It's not too interesting, but I think what is interesting is kind of the cross capability, cross-accessor use of Yara. And we're showcasing hitting Yara on disk as well as Yara in memory later on. I'm also showing a cool kind of decode use case that I like to show to make people kind of understand that Velociraptor is so powerful from a post-processing viewpoint. Same as previously, we've got the gist file that's got the script to run. And it's there. We've also got a Yara rule there that we can use as well. So first of all, let's run the script, and you can see here. What it's doing is it's just downloading a payload. It's then running it. And first of all, it's doing some cleanup of the prefetch, because at the end, I've also got a like a forensic kind of use case of showing prefetch handles to detection. So now we've generated our data. We'll come back and we're going to use a hunt. I've actually just ran that in testing, so we'll run it again. So first of all, I'll call it MS Build. We can choose where we want to run it. Now, I run hunts like this across like thousands of machines, and I might use a label here to target specific attributes or leave out specific things in that exclude condition. But what we're looking for is Yara, and we've got lots of Yara capabilities: Yara Glob, Yara Process, and Yara NTFS. Yara Glob and Yara NTFS do almost the same thing. The main difference is Yara NTFS will target that MFT artifact that I've showed previously in lab number 1. It can be a little bit more performant, but Glob is much nicer if you kind of know where you're targeting. In this case, we do. So we're targeting Windows temp. I've already copied the Yara rule here, and the Yara rule is just looking at some of the variable strings, and then just some of the strings for template files that you may expect, right? The condition at the bottom, we've just got a header search that's saying, give us that XML tag, that thing there, the less than sign, or a line break and less than sign. So that's pretty much straightforward. Like in this case, most of the time I wouldn't even use any kind of restrictions because it's very targeted. It's probably going to be a fast Yara rule for the most part. But say I was running like a more broader Yara, I might use things like an IOPS limit or a CPU limit to just improve performance and make sure that there is no user discomfort. Of course, when you're running queries, you've kind of got that trade-off where when you're targeting, and click the right button, when you're targeting a host, I find sometimes it's better just to have like hit the machine hard for like a second than spread that out over, say, an hour and have users notice that they've got, you know, an agent running or whatever. It really depends on the use case. So in this case, you can see the details. I'm only running it against one client and it's returned 1 row, and there's our detail. Actually, I think I need to run it again because I didn't upload. So we'll run it again. And select upload hits this time. It's very, very fast, you can see, so we can afford to do this. And the reason why I'm running it as a hunt is because I want to show this workflow that's kind of cool. I worked a gig where I had a whole bunch of these across many machines, and I wanted to collect them quickly and then decode them as well. You can see the results are exactly the same, but we've got this upload details. So to do that, we can do it in this notebook here, but I've actually pre-built a notebook here, so you don't need to watch me stumble typing all the time. And what I need to do is just add in this hunt ID, and it will show each sections. I think this is really important because it will show you kind of how I write VQL, and that's kind of easing into it. Like I don't try to kind of, you know, build Rome in a day. What I do is just do bit by bit. Often you find the VQL you end up with is kind of really messy to start with, but it works. It's exactly the same as if you're writing a piece of code for something, right? So you can see at the top, I'm just enumerating the flow, right? And I'll just go back and show this one because it's kind of cool. And what we're doing is we're just saying, hey, tell me all the flow, tell me all the job IDs in the hunt. If you were, say, just running a collection on a machine and you wanted to post-process it, you just do this part down here. You already know what the hunt is, so you're just looking at the flows. And that's the beauty of Velociraptor, is it's modular like that, and you can kind of do that. So there's that. This one, we're simply enumerating the host name and flows. Then this one down here is we're extracting the encoded payload. The big difference to this one that might not be apparent is I'm kind of outputting only 200 rows here. And the reason I do that, and the reason why I recommend doing that, is mostly for performance. When you're bouncing through kind of doing stuff like reverse engineering, often you might be looking at larger files. And just by putting out, like, say, 5 megs into the GUI, there's size limits, and we don't want to kind of have that. So just pushing out, the first 200 bytes gives you an idea of what you're looking at, and you can go from there. So in this case, I'm running the same process here. I've just simply added a capability to pretty much normalize the hex data. Yeah. And you can see I've created a function for that. So at the top, I've created a regex to extract the data. Then I've created a dynamic function that will normalize that hex data. And you can see I've just dumped it there to validate that it's working. And I'm just throwing it into a regex replace function here. As we move down, this is bigger. We've got extract bytes. So we're just doing the same thing, but we're going to extract bytes this time. Yep. So you can see I've just added read file. And again, I'm using that 200 limit, so it's easy to see. And you can see we have data here opposed to hex. Finally, we'll pipe these extracted bytes into a decoder, and you can see we can decode the cobalt stripe beacon. The only thing I'm doing that's differently here is I'm saying bytes equal, so that's the bytes row, and then down here I'm using the XOR function, and I'm using the key, and then I'm using the data bytes as well. Right, so it's a kind of cool use case of decoding that I think is useful, and this is from that file on the disk that I'm showing you in the notes that had essentially 2 hex encoded variables. One was the data blob of the beacon, and the other one was the key that was XORed. Okay, so the next thing I wanted to show was, let's go back into the host itself, was running the just Yara process over this, right? And I think I've watched another talk that has been up. We won't run Linux, we'll run Windows. And I think people have a good understanding of this, so we don't need to spend too much time on it. But the capability to run Yara, I have a specific carving artifact too that I can show. The capability to run Yara is super awesome. And I use this pretty much every gig to hunt down malware. And again, we can upload the process. I'm going to target it to make it good for demo. And I'll do the same here as well. Target that. And that will go out and it will return details of the binary. So you can kind of see we've simply had a detection of Yara, and what you can see here in the carving is the same kind of deal. I just kind of take it to the next level where once I have the initial detection for the Cobalt Strike configuration, I then try to carve it. Now, I've also built into this carver, essentially, if it can't find a config, it will show you the sleep. But I haven't kind of got a demo of that, but it should also tell you if it finds a sleeping beacon, as well as a few other things, like if there's an embedded beacon in like a binary section, if you're pointing it at a binary. Okay, so the next artifact I want to show is an artifact that enables us to query the VAD. And essentially what this enables us to do is query individual sections. So in this case, I'm going to target MS Build again. I'm going to look for read write executable and unmapped sections because, injection. I can configure it to upload again. But what I'm going to do is add a Yara of Cobalt Strike, the same as the detection before. And this is kind of helpful because it kind of lets us target individual sections. And it's a lot smaller file that we might want to upload, or we might want to get additional context. I find it just a lot easier to work with individual sections. And when this runs, you can see we've got a couple of hits. And we have the section name that it's flagged in. You can see, well, there's no mapping information because it's unmapped. You can see the protection, the size, the Yara hit. But one thing I haven't talked too much about is the process train. And in Velociraptor, something we haven't covered too much is our kind of process monitoring. We call it process tracker. What process tracker does is it kind of uses Sysmon or ETW or whatever you want to feed it to kind of store historical process events. So we can see exactly where this has originated from. I'm not actually running Sysmon in this lab, so by default it will use just PS list to give us the process chain. The final thing that I wanted to show from this kind of lab was my Prefetch Hunter. So Prefetch Hunter. Now this is an interesting one because Prefetch also stores like handles of files that are accessed by the process in the first few seconds. Now, what Velociraptor Prefetch Parser does is it enables us to kind of parse them out and produce like a row for each one and flatten the output. And what this artifact does is essentially lets us query that. Right, so you can see some of the configuration options I have is a glob. You can point that elsewhere if you want, if you're maybe doing offline analysis or whatever. You can filter by date, so you can box time here. Executable regex is MS Build. And then target regex. We're interested in temp files. So in this case, TMP. The reason why I'm showing this is because, number one, MS Build might be rare to run on a machine. Number two, temp's probably a bad example for MS Build, but you might be seeing in an engagement, or an actor might be using like XML, or might be using a unique kind of extension path. And it's these little combinations that, it might be really rare for, binary X to load extension Y, and you can hunt for that here. Or if they're loading a specific DLL or whatever. I've just found this a really interesting detection point, that you actually have a really long retention period when you're looking at prefetch files if it's a rare binary. When this runs, it's literally just going away and querying the prefetch, and we should have an entry for our file. I just think that's really cool and a really niche use case for detection. And that's pretty much it for this lab. Like I said, if you've got any questions, feel free to reach out. I really love doing this stuff. And for me, it's these little niche use cases or solving problems in the wild for real engagements that makes it really interesting. Okay, so just wrapping up our presentation, we haven't really covered everything that Velociraptor can do. And hopefully that you've like taken away from this workshop that like Velociraptor is a Swiss Army knife, and it's really up to the users what you get out of it. Hopefully I've done enough to inspire you for picking up the tool and kind of and getting to know it better. But here again is a link of learning opportunities and resources you can go to learn more. I really recommend the docs and present page for more information. Also, we've got a community at the bottom that is pretty active now, so feel free to join that and ask Velociraptor questions. That's pretty much it from me. So thank you for your time.